Hello guys, welcome to Consulting Technical Solutions. In today's tutorial, we are exploring PV simulation for a 100 megawatt grid connected system. Whether you are new to PV or looking to refine your skills, this step-by-step guide will walk you through the entire process, ensuring you can effectively model and analyze large-scale solar projects. Let's get started. First of all, the panels we are going to be used to design this PV system is Suntech, and the inverter we are going to be used that are the Sungrow. Let's move to PV Syst. Here we are going to, first of all, we have going to be import our OND and PAN files. First we have going to be import OND files. To import OND files, we have going to be first click on file and go to import component from folder. Okay, once you click on it, you will go into your designated folder where you drop your files. Okay, there is the PVSys. I'm going to my PVSys folder, and from here I'm going to be first of all select my OND files of my inverter, select it, and then the files will be opened. We have going to be select the inverter, that is the Sungrow inverter. I import the Sungrow inverter OND files. Yes. Okay, the files OND files are imported into the system. Now come back to import PAN files of my PV panel. The same steps I will be taking over here. Click on it and go to the Suntech PV pan files. Here we have going to be just select the folder, select folder. Now we come back here. That is all the PV panels, the panels on PAN files are prominent over here. We have going to be we with hold shift and select all the panels and then import on it and then click on yes, all right, and then yes, 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 and thus all the PAN files are imported into my system. Now close it, and the first thing we have going to be start a grid connected system. Then we have going to click the grid connected system. The first thing is that we have going to be save the project name, that is 100 megawatt PV solar grid connected demo. Okay, and the name of the project we have going to be save it. Now we have going to be add the geographical location. Please choose the geographical location site. For the geographical location site, we click on the plus button, and then we have going to be enter the geographical site. Here we have going to be add a new site. From here click a new site. Okay, then accept selected points. From here we have first select the region. It depends on your case where the region you are going to be design your project, and then the country from where you're going to be design your project. And now project name over here, grid 100 megawatt grid connected. Okay, this is the name of my project. Now we have going to be drop the latitude and the longitude. We open the Google Earth. From in this place we have going to be design our PV plant. From here, that is this solar plant 100 megawatt PV solar plant. Here we have going to be first select the latitude, Control C, and go to PVSys, then paste over here, and then come back to again Google Earth, and you will be copy longitude and go to the PVSys and drop latitude over here. And the second thing is the altitude. You will check the altitude from your Google Earth. From here the elevation is your altitude, actually that is the 53 meters. You will type here 53. The time zone depend on your project area where you are going to be design. In my case the time zone is 5. Okay, once I will put all the information, I will click on import. It will takes a bit time. Now the location will be selected as per your designated coordinates. Now click save. Okay, and yes, then again save the your geographical location. Here you will see that the selected weather data will be selected as per your designated coordinates. The second thing is that you will also copy and paste the latitudes over here. Okay, and the second, the same latitude will be copied and drop latitude over here. This is because of we have going to be, once we have going to be design our orientation, we need the latitude and the longitude. It's a traditional method. We have going to be select orientation, that is we have minus longitude our latitude, that is 42, then divided by 2. That is the angle that we have going to be use the tilt angle for our plant design. Okay, that is the tilt angle. First you have add the latitude and longitude, then once you have added from here, then you have going to be subtract longitude longitude to latitude, and then divide by 2, that is the 21, that is your tilt angle for your plant PV panels. Okay, now come back to PVsyst. From here we have going to first save the project first. Once you will save the project, the orientation bar is open for you. Okay, now you will first design the orientation for your site. As we already calculated the tilt angle for our project, that is 21. You will drop here 21. This is a traditional technique mostly we are used. The second thing is the azimuth. If you have any specific or designed azimuth, you will going to put your azimuth value over here. In my case, I will not specify any azimuth, that is the true southward. That's why I am not going to be assign any azimuth for my project design. Okay, it's depends on your case. So after once you will drop your plan tilt, then click on OK. Your orientation will be defined, what actually your orientation accordingly. The second thing is we are going to be design our system. For design our system, we already mentioned that we already imported OND and the pen files of our for our system. That is the pen file we inserted. That is, first of all we drop over here. We have going to design 100 megawatts. So we have going to 10 1 2 3 4 and 5 1 lakh kilowatt, that is equal to 100 megawatt. The second thing is that we have already imported the pen file of Suntech over here. We have going to have we have selected the Suntech module, select from here. Okay, that is the, we will search out here the Suntech module. From here we have going to be select Suntech, and we will use the maximum PV modules available in the system, because the design is in the megawatt. So we have the most highest PV module we have going to be select to design. If this system is in kilowatt, then definitely we have going to be a use small PV panels. If we are going to be design a large mega level projects, then we have going to be the topmost PV panel to design the system. We have going to be select the Sai Mono 420 WP panel for our system. The second thing is that we already import a SunGrow inverter in our system. We have search out here all inverters. We have going to be SunGrow, search our SunGrow here. Okay, you will select SunGrow inverter from here. There is we use the 2000 kilowatt panel for our system. Okay, once you select all these, you will define and design your system. Here once you will starting the design your system, you will make sure 2 to 3 checkpoints. The first thing is that the overload loss, it must be below 1, and the second is polynomial ratio. You have will be take in according to your module in series and the number of strings. And the third thing is that the maximum operating power, that is 96590, that is little bit less as per our designed power plant, that is 10,000 1 lakh kilowatts. So we have going to be increase our strings that will match our system, that is around 16 to 10 or 16 to 13 PV strings will be good. Yes, that is the 16 to 10 that is designed for our system is best. If we have increased somehow 310, then you will check 310 or 311, you will write it 321, check it, or 31, you will increase it till up to its increase above 1 leg. Okay, once it will meet your criteria, you will stop over there. That is little bit, I think it will going to be 4, that is undersize. You have going to be decrease the size. Okay, that is perfect. I think 4, 51 is, I think 4, 41 is the best side, 41 is not, that is 31 is okay, that is 31 is the acceptable. Okay, yeah, if you have going to be 32 or 33, you will move your system accordingly, and once you will meet your system, then after that you will, that is the perfect for it. Now it will, the maximum operating power is equal to the planned power. After you will select this, you will click on OK. Okay, then your system is going to be designed to operate further detail losses and the self consumption, etc. Okay, once you will define your system, after that the second thing, the third component is detail losses. Click on detail losses, you will identify the constant loss factor maximum. Mostly we are going to use 29 numbers. Okay, 29 watt meter square. Then the second thing is that we have going to be ohmic losses. You will check all these, you will must check the use as circuit ohmic losses if you are using this. Other than that, you will not check this. Okay, the module quality, you have to check all the points. You will define it is automatically default directed. You will not use to updation on it. The second thing and the third thing is the soiling loss. The soiling loss must you have be used as per your project area and its surrounding. In my case, I'm going to be used at 2%. Mostly the 2% is the common factor that is used around the globe. And the third thing is the IM losses and the auxiliary losses. You have must check the auxiliary losses, and the aging, you must check the aging loss as well. The third thing is unavailability, 1% unavailability chance. It's up to mostly it's a 1%. In some cases we have using 2% as well. The spectral correction, you have need to check this as well. After that, detail losses, you click on OK. That your detail losses will be selected as per your design system. Now we have going to, if you have any self consumption, that you are going to be select on it. Other than that, you will ignore this. And the third thing is the storage, and now the horizon is automatically, it's a default selected, default selected, so we are going to ignore also, ignore this horizon far. Okay, now we have going to be the near shading. This is the most important component in large solar PV system design. We have must to define a correct near shading. That's why it also impacted the performance ratio and the other shading losses, and this will be impact on the energy yield of your system. So we have to assign the near shading accordingly as per on the ground structures. To design near shading, you will go to Google Earth, from where you going to design your uh, solar plant. First of all, you will check out here, and then you have going to be define the project boundary. To design near shading, as you see on PVSys, we open near shading. Okay, from here we have going to be construction perspective. You will first identify, check out what actually you need, the orientation area, the active area you need, the number mentioned here 53948 meter square area you will be going to be construct your perspective shading scene. Click on it, and now you will go back to Google Earth, and from here we define the project boundary first. To define the project boundary, you will select here and name it project boundary first. Okay, then the style and color you are going to be just outlined. From here the project boundary will be start. Click on the boundaries. Okay, you will drop it side on side so you can easily detect your project boundary. The second thing is, the third point is here, and now move for here, and this is the last point. This is the project boundary. I think this will be settled over here, third point, and the last point. You will adjust accordingly. This is just demo. We are going to be design how we're going to be design near shading as per the ground feature and the structures. So you have to first define your project boundary. Once you define your project boundary, after that you will click OK. This is the total project boundary area. Here the place where we are interested to install a PV plant. That there are a number of features in this lane, as you know. This is the scene that there is the grid area, there are the wind turbines over there. You will see here, these are the wind turbines. So we have going to be design in between the wind turbine. So we have select first the project lane for where you going to install your PV modules. Okay, I will select this lane and this lane as well, and the third point is this one. Okay, this lane also we utilize for our solar, this area as well. Okay, this area we are going to utilize our PV solar area. Okay, you will move it further. You will see on the ground where the shading must be not be impact the PV solar where you are going to be installed. It's be a bit far from the WTGs where the wind turbines are. Over there is the building shading. The chances of the building shading, so we have avoid these areas. Okay, this is the area where we are going to be install our PV system. That is the 100 megawatt PV plant will going to be designed over here. There is the 434 acres of land. Normally we are going to be, the thumb rule is the 4 acre of land we are going to be using for 1 megawatt actually. Okay, this is the common concepts where we are going to use 4 acres of land. So we have 434 acres of land. We go back to our Excel file. You will copy over here project lane area, project lane area. Okay, total lane acres, there is 434 area required per megawatt. That is 4 acres of land. So the capacity of our project is, it was 100 megawatt. Okay, So how do we define how many lane will require to this 100-acre lane? So for 1 megawatt we need 4 acres of land, so we need any 400-acre lane are required for our total plant capacity. Okay, the 400 acres of land are required, so we have extra 34 acres of land. We have extra land we will use in future for further extension or any great expansion or any of other purposes. We are going to be used the extra land for our other infrastructures, etc. All right, now come back to PVSys. Here we have going to be import the image. We see now here this is the total lane where we have going to be design our PV module. You will check from here. Once you will save it, the view area is total area is this. We use this lane for our PV sharing. Once you will visualize and zoom the exact lane boundary, after that you will click here save image. Now you click check all these points and click the maximum resolution, and now save image. Go back to this designated folder. Okay, here 100 megawatt shading image. We use this image for our PV installations. Now you click on save. It will take a time and save a high resolution imagery on a respective folder. Okay, the image is saved in your respective folder. You will check from here. The image is saved over here. That is a high resolution image. We can see here the boundary, the main boundary of the project, the main boundary of your PV solar where you are going to install. Now come back to your PV shading on PVSys, then click on file and import the image into your respective folder. You will go back and open the image where you saved. Okay, this is the image we are going to yes, this is the image we are going to be use for our PV plant. Now the thing is that we have going to be scale up the project. To scale up the project, you have first any of the objects select from your imagery and take the length from Google Earth and drop the same length on this area. Okay, in this attribute you will first we go to Google Earth. This is the prominent feature where we have going to scale up our imagery. You will check it the length in meters from point x1 to point x2. The length is 128 meters, somehow 128 meters. Okay, now come back to your PVSys file, select define x1, and the second point is your here is x2. Now you will drop the actual length in meter, 128 meter, drop over here and click apply. Now you will check your image is scale up. Now you can design your project within this project lane, and you will also drop the turbines and the other infrastructures like buildings and all the related shading structures you will drop over here. Okay, now we're going to be start to first the related structures, especially the wind turbines. From here there is the one thing is here is the wind turbine is over here, one thing. The second obstacle is over here. All the wind turbines we have start to plot from turbine 1 to the end. Okay, the first turbine is here. Click here elementary shading object. Here you will find the wind turbine. So we have to identify what actually the stand height, what actually the width and of the blade and the diameter of the blade, and all the points we have going to move to ChatGPT. From over here you will type, or please provide information about the wind turbine below components: blade length, hub height, and the rotor diameter. ChatGPT will provide all the related information: the blade length, that is the strip output, the height, that is the typical blade length is 40 to 60 meters. Okay, the hub height is around 80 to 120 meters. The rotor diameter is around, it's 130 meters or 150 meters. So you have going to be identify, and you will calculate all the heights and the lengths of your turbine. Go back, we have identified here that is the height of the stain is around 87 meters, the lower diameter is the same, and the length of the blade is around, blade full length is around 45. Okay, rest of the details, that is generator diameter is 4 and the length is the 5, that is perfect for me. It depends on your case. If you have changed any length or any height, then it depends on your case. In my case I use 90 meter stand height, and the rest of the informations I will use the same informations as default. I will click close the object. Now come back to your settings. From here you will click modify and drop the first turbine where you seen your first turbine. My first turbine is over here. I install my first turbine location from here. Now the second turbine over here, same the steps of we will taken for the rest of this step. The turbines you will control C and then control V. The all turbines will be placed accordingly. Okay, I'm here pausing my video. After that I will drop all the turbines on your locations. After that again resume the video. Okay guys, here you've seen all the turbines are placed accordingly their places as per the system we have going to be designed accordingly. You will see now here we have dropped all the turbines. Okay, and the second thing is that the second obstacle is the building over here, that is in the middle of the project lane, that is the grid area. So we have going to be create a grid area over here. They click elementary shading object. From here we going to be select the home house two side roof bar. Click the width of the uh, grid area, the building area. From here we check there are the 2 to 3 buildings. There are the small obstacles over here. We have going to be also put the same length over here, that is the width is 187 meters, the width is 52 meters, 187 and 52. Come back to PVSys here, 187 width, and the second thing is 52, it's 187 length and 52 width. There is no angle of the roof, it's depend on your case, 0, and close it. Here we have dropped the first building, and now same you will calculate the length of this building as well, that is 84 and 34 meters, 84 and 34 modified settings, that is 84 length and 34, and you will change the rooftop of the second building, close on it, and you will move and install the building accordingly. and there is one building over here. I think this will not impact the plant PV panel, but still we drop the building over here for the learning purpose. And no, that is the third building. We will change the color of all these building roofs as well. You will select over here and click the change the colors of the roofs of all buildings. Now you will see render it, and you will in 3D look. Okay, you will check out modified and click here. This is the buildings where we are going to install if it will impact on the solar panel. Okay, now come back to create the shading and install the PV modules. Start from here, we will click create and array table. There are the number of modules are 3, so it depends on your case. I'm going to be select 100. Number of shades are a little bit 60. The pitch we are going to be using is around 10 to 13. We use 10. It depends on your case. The panels orientation we use on orientation on landscape. So number of modules on length to 5. I will use it's around 50 or more. 50, I think it's 50 is the is good, because after 50 we use roads or any crossway paths, so we use just 50-meter length modules. Then we have going to be use the number of modules at height it's 2. Okay, now come back to the system, then click close. Here you will see in the PV module, you will click on it. Okay, then modify it. You will move and drop whether you going to be design your PV area. Okay, I'm starting from here. Okay, after that, if you increase the number of shirts, you will increase from up to 60. And the second thing is that we have going to be increase the number of shirts as well. It's up to 63. Close it. You will see now here we will change accordingly. The second thing is that we have Control C and Control V. If you want to drop it over here, we will give gap around its 20 meter or somehow 6 meter. Okay, you will check the length from point 1 to point 2. It's around 24 meter. You will use it 15 meter. Okay, so you have click here and modify. You will move just placed over here. Okay, now click on modified, and now you will click over there and you will see this is the panels. Okay, if there is the chance of shading of this, so turbine you will move slightly up. Okay, so you will Control C, Control V, the same place we have placed over here, and the same thing we have Control V and place over here. And then we also placed the PV panel over here. Okay, the same steps will be taken all in this portion as well. Once you will completed your PV shading, you will check from here, close the scene. You will check over here, we need 5, 3, 9, 4 and 7. It's 82720. The area of 3D field lower than the area of the modules defined in the system. Still to meet this orientation area, you will increase your panels. Once you will meet the criteria and the PV area, after that you will run the simulation table. Okay, the second point is over here. Now we install some panels over here in this region as well. This is our area where we are going to define for our system. Okay, modify it and you will move accordingly. Here you will be decrease the size of your PV number of modules in length. It's up to 60 or it's less than 40 or 30. Close it and you will check. I think 30 is the perfect size to fit in the polygon. You will check it. Okay, now you'll come back to the panel and yes, and click check it. If you still need some increase of the numbers, you will till meet to the your PV panel area, you will increase the PV modules accordingly. Okay, after that, once you will complete your PV shading over here, then you are going to be run the simulation table. Okay guys, once you have going to be drop and create all the shadings as per the requirement and the need of your system, you will check it. Okay, this is the grid area and these are the WTGs, and once you will check it, and after that you will see all the directions from where if any of structure that will be impact on the shading on the PV module, then you definitely you will be move and change the structure or decrease the number of the PV shades accordingly. Okay, once you will done it, you will close on it and click yes. Here now we need to shading factor table to compute the shading table. You will click the table and then it will be computed the shading factor. Okay, it will take a time. You will just wait. Once completed the computing shading factor table, after that it will appear a successful message and then you will back to the system. Okay, that's perfect. Okay, the shading orientation is computed over here. That is the shading factor for diffuser is 0.017 and the albedo is 0.651. Now click on H and OK. Now the shading is also computed, or orientation is okay, system is okay, detail loss are done. If you have any self consumption, you are going to be drop it, and if you have any storage, or sometimes we have going to be used in a hybrid as a generator or any sort of genset or any other energy like WTG's energy are used or any some other sources, you will click on it and you will be click the storage. And sometimes if you have going any battery system and you have going to be storage accordingly, then you have going to be storage system, you will install the best system and you will incorporate it and you will going to be run your simulations. Now the second thing is the module layout, that is already done. Okay, then the energy management and near shading already done. Now we will going to be simulate the final report. You will click on the run simulation. Okay, the simulation is done, almost done, that's perfect. Now you will check the report, click the report. Okay, that's perfect. Now you will see the report, what actually we have going to be Now the geographical side, that is 100 grid connected, the latitude, longitude, the project summary is over here. The albedo factor is also mentioned here, 0.20, it's acceptable. The second thing is the system summary, and now the near shading. And now we will come back what actually the table of contents, that is the project and result summaries. We will see one by one. The first thing is the shades on ground, that is the we have not any defined any azimuth, but the tilt is 21, that we have already defined as per the initial setups. And the module used, that is the the all details of the modules and the metronome data. And sometimes we have going to be using solar GIS data. In this our case, we have going to be just work on metronome data. If we using any solar GIS data, we first incorporate the solar GIS data in our before our simulation. After that we run the our final report simulations. Okay, and down the horizon, that is the free horizon, the near shading is there, the PV array characteristics all are dimensioned over here. Now the second thing is that we have going to be use the array losses, that is the 1.5 STC, that is for a mega level it is acceptable. Okay, are the array losses here is mentioned, and the system losses, availability, auxiliary losses over there, that is the negligible. The AC line, AC wiring losses are not at that much high. So you have seen here that that is the your PV module area, the shading scene. In I also some other techniques to show the PV shading scene in your report. I will take the steps and to export the PV shadings in this video also. There is the PV performance ratio in this report is showing over here. That is the perfect. This is pyramid ratio is 78.23%. That for a high projects, for the mega level projects, the 78.23 is acceptable. When you working with the solar GIS data, then definitely it will be increases. This is the near shading losses diagram. This is the most important. Once you have finalizing your report, before that you have going to be analyze all the near shading, especially the global incident and the near shading losses, and all that there is the acceptable, not is any loss that is more than the acceptable level. So the report is acceptable for the this case. Okay, the system output power distribution, the graph is the perfect. That is the final single line diagram over here. That is the 15 STP 420, that is the 15 inverters and the injecting point, and for this is designed for our, this is our system. Okay, this is the final report. Now you can use save as a document your file, or any other uses. You will be export any specific task from over here. You will select it, and you have, if you have any project name, yeah, meteor data, or any some other files names, etc., you will export each and every component from here. Okay, now I will just teach how we use the near shading as the image. Okay, you will come back over here. This is your 3D render image. Okay, this is your image. Now you click file. Now you be here export, save as the image in the report. Right, export shading scene, control C, and then you have save the near shading as SHD file as well. If you're using further any different case, it's up to you. Now you want to save this image, this is an image or any format, save over here, click on it and go back to the designated folder. Okay, and then you will save here is a JPG folder. Okay, the final shading scene, click over here. Now type final shading scene, save it, successfully saved. Go back to your file and check it. That's perfect. That is the your shading scene. Now you will compare both of the images. You will check over here. This is the image that you initially created. That is your second image that your PV panels are installed over there. Okay, that's perfect. That's cool. I think you will cover all the aspects in this video. I think everyone will be easily now simulation and all the steps, all the components were easily explained and all the steps were be done over here. Now if now you will be, the second thing is that if you are working in another variant, you are not going to be the same variant, you will save over here the same variant, new say new. If you are going to be another simulation with another variant, you will click over the name of the VC2 from over here and save as a new. Okay, then you will work on the second. If you have work on this the second variant, then you are going to be number of variants you will create it over here. For suppose you are working with different PV modules or different working with different panels or any different inverters, you are going to be system is will be different, then you will be created one by one the different modules over here and you are going to be save the new variants. Then the variants will be our edit over here, you will be work with the different variants. I think this is done for the grid connected system. I hope you will like this video. Thank you so much for watching this video. Please drop any comment if you have any confusion, if you have any sort of any component that you are not understanding clearly. Please drop your message. And moreover, I also created number of PVSys related videos. That is the complete course. If you visit my channel Consult Technical Safe, go to playlist. Over here you will visit the PVSys complete course. Click over here, you will see here the all in this checklist. I'm going to create it all related videos about PVSys. I think it will give you a complete information about PVSys. That's all from my side. Thank you so much. Thank you so much for watching this video. Please like and comment. If you are not subscribed this channel, please subscribe the channel, and in future I will also share some technical related videos about PVSys and other related softwares, and also going to be some attempt on the renewable energy related to resource mapping related to the solar and wind as well. Thank you so much for watching. Take care. Bye.